Alright, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video and I'll go over the correct answers. So for this one, you're going to want to factor out a 2 from each of these. So you're going to have 2 and then x squared plus 3x minus 54. And then you can factor x squared plus 3x minus 54. You don't want to do remove, replace, reduce here because you have to make sure to remove the greatest common factor first. So if you factor, you'll have x plus 9 and then x minus 6 for your answer. Okay, for the math knowledge question, these show up on the ACT kind of often, I feel like. This thing, you're just going to plug it into that formula. And so they give you A, B, C, and D as 2, 1, 4, and 6. So you just plug them into this thing right here. So our A is 2. Our C is 4. Our B is 1, and our D is 6. And then A is 2. B is 1. C is 4. And D is 6. So then you have 8 plus 6 over 2 minus 24. So 8 plus 6, 14. 2 minus 24 is negative 22. And those both divide by 2, so you get negative 7 over 11. And so that would be your answer there. So we're looking at lesson 47 today. Fundamental theorem of calculus part 1 and the definite integral. So we've looked at the indefinite integral before. We haven't looked at definite integrals. So hopefully you'll understand the fundamental theorem of calculus and you'll understand the definite integral. So the fundamental theorem of calculus uses definite integrals. This is a definite integral. The reason it's called a definite integral, we have endpoints of A and B. And so we are actually going to evaluate this. We're going to integrate, and then we're going to be plugging in our A and our B. So this is the theorem of calculus. Suppose f is a continuous function on the closed interval from A to B. And f is the antiderivative, or the integral of lowercase f. Then when you have your definite integral, you're going to integrate it, and then you're going to take b and plug it into your function that you get, and then you're going to subtract whatever you got when you plugged in a. So that's how that works. You always plug the top one in first, and then this one in second. So we want to find the area under the graph of this function between 0 and pi. So whenever it asks you to find area, you're actually going to be using the fundamental theorem of calculus. So we're going to set up our function, and we're going from 0 to pi, and the function they give us is 4 sine of x and then dx. Okay, so now we're going to integrate. So if you integrate sine, let's guess 4 cosine. Is the derivative of cosine sine? The derivative of cosine is negative sine, so we should have negative 4 cosines of x. Okay, so now we're going to evaluate it from pi to 0. That means evaluate from pi to 0. So we're going to say negative 4 cosine of pi, and then minus negative 4 cosine of 0. So minus a negative became a positive. So if we plug in what cosine of 1 is, that's a negative 1. And if we plug in what cosine of 0 is, that is a 1. We can solve for our answer. And we'll get 4 plus 4, which is 8. And so that would be the area under the graph of 4 sine of x between 0 and pi. Okay, so the value at the left end is called the lower limit of integration, and the value at the right end is called the upper limit of integration. So you always plug in the upper limit and then subtract and plug in the lower limit. Okay? So evaluate it by doing the upper limit first, subtract, and then plug in the lower limit value. That's all you have to do for area under a curve. So we want to evaluate this. So it doesn't say what is the area under the curve. It just says evaluate your integral. But that's what you're finding. We are going to be finding the area under this parabola from 1 to 3. So we first have to integrate. So if you integrate x squared, you should get 1/3 x cubed. If you integrate 2x, you should get x squared. And if you integrate 5, you should get 5x. Now you don't need to worry about doing a plus c on these because the c is going to get canceled out because you're going to have a plus c, and then when you plug in 3 you'll have plus a c, and then when you plug in 1 you'll have a minus a c, and so they'll cancel. So when you're doing a definite integral you do not need to put a plus c. And we're going to evaluate it from 3 to 1. So we're going to plug in 3. That's all the upper limit. And we're going to subtract and plug in 1. And then from here you just need to simplify. So I end up with 9 plus 9 plus 15 minus 1/3 plus 1 plus 6. So 9 plus 9 plus 15 is 33. And then we have minus 1/3 and minus 7. So 33 minus 7 gives you 26. So I have 26 minus 1/3. I multiplied wrong here, guys. Goodness, y'all probably already noticed it. This should be a 5. So this would be 6. So this would be 27. So 27 minus 1/3 would be 80/3. And so that would be your answer. Sorry about that. Y'all were probably sitting there noticing it already. But that's how you evaluate your definite integrals. Okay, so we're going to look at another example. If y'all think you can integrate this one and plug it in by yourself, go ahead and do that. And then I can go over it. Your answer for this one is, you can have it as a decimal, but they're usually going to leave it as not a decimal. So it'll look something like this. If you integrate 3e to the x, you'll get 3e to the x. What is the integration of 2 over x? 2 ln of the absolute value of x. And then the integration of x squared would be 1/3 x cubed, and we're going from 2 to 1. So if you plug in 2, you're going to have 3e squared plus 2 ln of 2, and then plus 1/3 2 cubed. Then you're going to plug in 1. So 3e to the 1 plus 2 ln of 1, and then plus 1/3 1 cubed. From there, you're just going to simplify. So 3e squared is 3e squared. 2 ln of 2 is 2 ln of 2. And then plus 8/3 minus 3e to the 1 ln of 1 is 0, so 2 times 0 is 0, and then we have minus 1/3. The only two that can be combined are these two, so we end up with 3e squared plus 2 ln of 2 minus 3e, and then plus 7/3. And so that's your answer there. And again, you can get a decimal, but there's really no reason to plug it into your calculator because you've got your answer already. So that's how you do fundamental theorem of calculus. That's what it's telling you to do. Now we're going to look at finding this geometrically. So when it says geometrically, you need to look at the graph. So for sine, it always starts at the origin. And this right here is 2 pi. And this right here is pi. This area and this area are the same, except for that this is a positive area because it's above the x-axis, and this is a negative area because it's below the x-axis. So it says find the area of it geometrically. So it's asking to just look at the graph. If this is the same area as this, and one's positive and one's negative, then the answer is 0. We don't even have to evaluate it because we know that they're going to cancel out. So that would be your answer for that one. Okay, if it wanted you to actually find, like, what is the area not geometrically, and it wanted to know what was the area between the curve and the x-axis, you would have to integrate from 0 to pi, and then you could just double that to find the total area, this, and then just do times 2, basically. That would be if you wanted to know what the area actually was. But it said find it geometrically, so we didn't need to do anything, really, because they were going to cancel out. Alright, so looking at this one, we want to evaluate this integral. So that means to integrate and then plug in. So if we integrate, we get 8x minus x squared from 4 to 0. And then we're going to plug in 4. And then when we plug in 0, we subtract it. So now you just simplify. So you get 32 minus 16, and then minus 0 is 0. So 32 minus 16 is 16. And so there's your answer. So that's how you do definite integrals. You just have to integrate and then plug in your upper limit, subtract, and plug in your lower limit. So make sure that you do your homework tonight. You do get to omit number 17, and you get to omit number 22. So hopefully you'll be able to do the rest of them, and we can go over any questions you have tomorrow.